Okay, so back at the IR spectrum looked good. We got our plastic from the inside of the instrument, just under 3,000. We got the carbon dioxide peak. I guess I'm breathing in the room. There's carbon dioxide in the room. And then some water. So anyways, it's looking good, and I like to delete it right now. Now, for unknown 2. Got my NMR tube. Well, this one's got a bit much of TMS. I'm going to try to pour a little bit out. Sometimes you just like start to pour it and it evaporates so quickly. Let's see. Came down pretty good. What do you think? A little better? Yeah, it was okay the way it was, but I'll make it a little less. All right, so I'm going to pipette up some up unknown number 2. Draw it up and see if it's real drippy. Oh, it's not too bad. I'm going to still spit some out. You're going to see some of them are more volatile than others. Okay, so start filling this up to the line. Here we go, right about 4 centimeters. That's good. And then I'm going to pick my cap color. I got a green one. Let's go green. Okay, and then we'll flip it over, invert it, let it mix. Mix. Okay, this NMR tube is ready. I got 2 ready. And I'm going to take that pipette and go over and get the IR of this one. I don't need the pipette bulb on there. Just walk it over and we'll watch from here. So I already cleaned off the IR window. I should have showed you that actually. So I remember I took a chem wipe, mopped up the last liquid, and then I wet the chem wipe with ethanol, and I wiped it off, and then I used a dry chem wipe. So it's nice and dry. I got a little bit of unknown here. Just going to push my thumb on the end of the pipette. There we go, looking good. So I'll come over to our software. Click. I already deleted the old spectrum, so I'm going to click Instrument, Scan Sample, select the default values, okay, and let it start scanning. See what this one looks like, see if it looks different than the last one. The last one definitely had a carbonyl in it. It's doing the 4 scans, and there's one of the 4. I don't think I see any carbonyls this time. So this unknown doesn't seem to have a carbonyl, probably not a ketone, aldehyde, ester. And I'm going to overwrite the last one. Yeah, it looks pretty good, huh? So let's go to the vertical cursor. I could turn the vertical cursor on. Oh, it was already on. I just turned it off again. Now I could turn it on again. Oh, it's way over here. There it is. And I could turn it. Why would I turn it off? Okay, so here we go. Let's see what this first one is. Right around 3,000. The SP3, SP2 carbon Mason-Dixon line here. Double click. Oh, a little over 3,000. Looks like SP2 carbon hydrogens. And I did mention this before, these little bumps right in here, they're the aromatic overtones, probably have an aromatic. Is this the carbonyl? No, that's not a carbonyl. We're over here in the fingerprint region. So yep, no carbonyl for this guy. And I can label a couple more. Maybe I've labeled this really strong one on the end here. And I can squeeze my screen together too. I'll push up on the monitor here, push down on here. It's kind of a delay, but all of a sudden it'll pinch it down. Let's see, oh, there it is. See, yep, I got it. Got that done. And then, so my text box says unknown 1. That's not right. This is now unknown 2. Did I do it? Yeah. Okay, so I got unknown 2. Run by me a little before Halloween on the 27th. And there we go. Oh, I should move this one over. And I'm going to screen capture this and save it, and I'll share it with you guys later. And I forgot to do this last time, but let me show you how I clean off the sample this time. So I'm going to get a chem wipe. I'm going to come over. I'm going to mop up most of that liquid sample. Put that in the waste container. Take another chem wipe. Get it a little wet with ethanol. So that's my ethanol. cleaning solvent. Bring that over and wipe off the ATR adapter with that. Give a nice ethanol wash on that guy. Put that in the waste container. Grab a dry chem wipe. Dry this off. And we're ready for our next sample, unknown number 3. See you in a sec. Now for unknown 2, green cap. There we go. I was away from lab for a while now, so I'm just getting back at this. I bet I'm gonna have to shim this because it's been over a week since I used the NMR. Okay, I got the right height, and now let me put it in and see if we can get it spinning. Okay, so it's floating in the air there. See, oh, yep, there it is. Now I'm gonna sink it down by, I could hit inject, but that has a faulty button. So if I just hit off, it does the same thing as inject. You turn off the air source for a moment, it drops down, and then I'm going to start it spinning, hopefully. There it goes, I saw good. Alright, now over to the NMR. Alright, here we are. We are in the proton setting already. So I just hit ZG and ZG, enter. It's going to ask me to give it the default name, and I'm going to hit enter again to accept that. And so this first scan will probably be looking funky, and I'll have to shim it, which is good experience. Here's the FID, so now I go into nuts. Nuts is down here. First time I open it, it asks me to accept whatever. Now the command to bring it over is the letter A and the number 2. Don't have to hit enter, and yeah, this looks, yeah, definitely like it needs some help, huh? See how the TMS is not a singlet, it's not quite a 0. Let's go back over to AII PNMR and type the command SHIM, hit enter. Now the relaxation delay, we're going to make a guess, we'll say 2 every time. So it'll start off with the relaxation delay of 2, and then it'll adjust it over time. So it's adjusted receiver gain first, now it's shimming the C and Y electromagnets. It's adjusting them to try to make the magnetic field as homogeneous as possible throughout the samples too. And shouldn't take too long. So the relaxation delay we were talking about earlier, that's like how long it waits between pulses. So it pulses all the radio waves, excites the hydrogens, and then lets them relax. And then while they relax for, it lets it relax for 2 seconds, and then it pulses again. And it checks this, and it actually, right now it says it's doing a relaxation delay at 2 seconds there, right? But it's probably going to adjust it. Lately it's been going to 3, so maybe we should be guessing 3. That when we make that 2-second guess, we're just trying to get it close to what it might be, so the machine doesn't have to take a long time figuring it out. Kind of like calculus, if you ever done problems like max-min problems. So here we go, we're getting closer. Once this is done, we'll just ZG it again. Oh, so it's done. So let's see what the relaxation delay go to. Oh, the relaxation delay went to 3 seconds. Yep. So I could have put that. Maybe next time I'll do that, so go a little quicker. All right, so now I'm going to type ZG again to get the scans. Oh, it's going too right. There we go. ZG. Enter. Enter again to accept the default name. Shouldn't take long. I think it's like 8 seconds. Yeah, acquisition time 18.19 or 8.19 seconds. There we go, got our FID. Let's go over to nuts. And we're in the zoom subroutine currently. I want to get back to the base level. So I hit enter, base level, and now to bring over our spectrum, it's again the letter A, the number 2. There it is. Look at that, so much better, huh? TMS is a singlet. Got it. These signals out here, I'm not sure if it's coupling or spinning sidebands. The silicon atom has, I think, like 24% of an isotope with a spin of 1/2. and that will cause a doublet along with the singlet, but I don't know if it's tighter or I'm not sure. There's this other thing called spinning side bands. It has to do with shimming. And if your shims are great, you don't have them. But if they're really good, you have them. And when they're not good, you don't see them. So this is normal. All right, so I'm going to click and hold, and then I got to type the letter M to see where TMS is. So I've typed M. And yep, it shows me at TMS is at, what is that, 1.008. Okay, so let's correct that. Come back over to AII PNMR and type FO, frequency offset. And then, oh, I had the wrong thing. F90. Okay. FO, frequency offset. Now I gotta hit enter. It'll ask for the current position, which was 1.008 parts per million. And I hit OK, and then it says, where do I want it? I want it at 0. Okay, so that is corrected in this software, in the AII PNMR. I've corrected that. But I still don't have that data. I don't have new data with that correction in the NUTS program, so it's still over at 1.008. So a lot of times students get confused, but all you gotta do is rescan ZG, enter, wait another 8 seconds, and then we'll bring that spectrum over. There we go. And now I'll go over to NUTS, and I'm in the base level, and so I'll just type the letter A, the number 2, and look at that. TMS is pretty close to 0 now. I'm going to do the minimum peak height thing too. I'll go like here. Type M. And it's a little bit off, negative 0.063. That's close enough for me. Okay, so I'm going to process it. I'm going to double click to get into zoom. Drag a box over my main area where my signals are. Now I'm going to hit enter to get back to the base level from zoom. And now I'm going to hit the, what am I doing after that? The text box. And what's the command for that? Does anybody know? No, you don't know? No? No? No is right. NO. So you type NO, and now we're in the text box subroutine. It says enter notes there. And then we have to type the letter A to add. It's okay. So this is unknown 2, huh? I'm just going to write unknown 2. I should write my name and all that, but I'm going to have you guys put your name on this, so this doesn't need to have a lot of details just right now. Okay, so I'm still in the notes subroutine. I got to get out of that. I'll hit enter. Now I'm base level. Now the last thing I got to do is integrate. So I type ID. And here's my integration curve, and I want to chop it up around my main area, my main signal. So I'm going to do 2 clicks on the left here. Makes a green line. And then I'm going to go into the middle. I'm going to integrate like the 2 like messy chunks of this. And then I did 2 clicks there. I did 1 click there, and I did 2 clicks here, and then 1 click there, and that's it. Now I just had to assign one of these. So this looks to me like a 2 to 3 ratio. Doesn't it look like 2 to 3 to you? So I'll click once, and I'll type the letter V, and I'm going to assign this one 2. So, okay. Yeah, that's really good. So that looks like a 2 hydrogen signal and a 3 hydrogen signal. And this is in the aromatic region, so that makes sense to me. Maybe it's 5 hydrogens on a benzene ring. And yeah, got one other thing on the benzene ring. All right, so I'm going to collect this data for you, and I'll share it later. Okay, now we're going to run the carbon NMR for unknown 2. Right now we're in the proton NMR setting, so I got to type the command NU space C13, and then nothing happens, so I'll hit enter. Now I'm in the carbon 13 NMR spectrum setting. So then I type ZG, enter, and I get my scan starting, and you can see it says running ZG with BB decoupling, so broadband decoupling. It's decoupling the proton NMR coupling by hitting it with the broad band of proton NMR radio waves, the 15 megahertz range. Oh wait, yeah. So you can see it's saying nucleus is carbon 13, and the frequency is 15.089 megahertz. That's the decoupling frequency. Oh no, I'm sorry. That's the carbon NMR frequency, 15 megahertz, and then This is the second dimension. This is the decoupling. It's decoupling hydrogens that are at around 60 megahertz with the spectral width of 1,000 hertz around the 60 megahertz area. There we go. So we're 9 of 12 completed. So when we get to 12, which should be more than enough, we'll look at our spectrum. It should look really nice. Done. This little dialog box pops up to tell you it's done. So okay. And then we bring it to nuts. And in nuts, make sure in the base level as always. And then the way you bring it over is you type the command control, hold control, and then the F3 key. And it'll ask you, do you want to open up the default named one? And say yes, because that's what we've saved it as. Line broadening, it's 0.5. And then we hit OK. And then OK on this too. And there it is. Looks like we got 1, 2, 3, 4 signals, all in maybe the aromatic region, huh? And we're seeing a nice table of 4. So I don't have to set my minimum peak height. And these 4 are overlapping. So I'm going to go to view and get rid of those peak labels. Just have the table. And now I'll add a text box, NOA. So this is unknown 2. I'm just going to make a real brief text box. You guys are going to write your name and date and things on it as if you took it. So then I'll put that there and I'll hit enter to get out of the notes. And I'll collect this spectrum and share it with you.